Next up, we have Robert von Holle, who will be discussing active galactic nuclei and the correlated properties of neighboring galaxies.
Hello, I should put this in presenting mode. Hello, I'm Robert von Holle, and I'm going to be talking about active galactic nuclei and the correlated properties of neighboring galaxies. When a galaxy's central supermassive black hole is actively accreting matter, it becomes known as an active galactic nucleus, or AGN. You can see on the plot on the right here, the spectra of a normal galaxy in the bottom left, surrounded by the spectra of a variety of different types of AGN. You'll notice that these AGN spectra look very different from the normal galaxy spectra, and they also tend to be significantly brighter on certain wavelengths. Because of this difference in brightness, distant AGN are easier to see than distant normal galaxies, so they can provide us some helpful hints in figuring out how the universe has evolved over its lifetime. This summer, I sought to answer the question, given a set of target galaxies, what properties of those targets nearby neighboring galaxies result in a higher likelihood of those targets having AGN? To this end, I collected a sample of about 6.86 times 10 to the 5th galaxies from the Sloan Digital Sky Survey database with these limiting factors: an apparent U-band magnitude of less than or equal to 24.25, an apparent R-band magnitude of less than or equal to 17.77, and a redshift between 0.004 and 0.25. On the right here, I have a plot of my galaxy sample. The x-axis shows the color, denoted by the U-band magnitude minus the R-band magnitude. So the further right on this plot a galaxy is, the redder it is, and usually the older it is. And on the y-axis, I have the absolute magnitude of the galaxies, which is a measure of the total energy that the galaxy emits. I have this axis inverted because the lower the magnitude, the more energy the galaxy emits. So the higher on this plot a galaxy is, the brighter it tends to be. I then divided these galaxies into groups based on their number of nearby neighboring galaxies and found the fraction of each group containing AGN. I found that there seems to be a strong inverse correlation between the number of galaxies within half a megaparsec, or about 1.6 million light years, of a target, and the fraction of those targets containing AGN. Now, projection error may have had an effect on this result. That means that two galaxies that are very physically distant from each other can appear to be nearby neighbors if they are in roughly the same area of the sky. I did impose some redshift restrictions to try to limit this effect, but I was unable to eliminate it entirely. However, in the extreme example that no galaxies have nearby neighbors, and this is entirely a result of projection error, we would expect to see no correlation between the number of nearby neighbors, and the fraction of targets having AGN, because galaxies that distant from each other won't really physically interact in any meaningful way. Because of this, I believe it's much more likely for projection error to dilute a correlation rather than cause it. So I believe that this correlation is actually representative of a physical phenomenon. This negative correlation is also strong at shorter distances. Here I have a plot comparing the number of galaxies within 1/10 of a megaparsec of a target and the fraction of those targets containing AGN. And you'll notice that this correlation is still very strong at this distance. Something else that's a little bit difficult to tell from this graphic alone is that this first bin I have, representing 0 nearby neighbors, accounts for about 87% of my sample. Because we don't expect to see many galaxies with a large number of neighbors within 1/10 of a megaparsec, this seems to be roughly accurate, which is another clue to me that projection error is not playing too significant a part in messing up my sample. However, further investigation is required to cut down on the influence of projection error. Another future avenue I can take with this research is to consider other properties of neighboring galaxies that may lead to the formation of AGN. For example, are AGN more abundant in all red groups or all blue groups? In mixed groups, do AGN tend to lie in the red galaxies or the blue galaxies? This is something I'm working on currently and don't have any results to show for quite yet, but I hope that these preliminary results that I have been able to show have proven interesting nonetheless. Thank you, and do you have any questions?
Thank you so much, Robert.
Can I have a question?
Yes, absolutely.
Did I understand it right that basically you can just have the galaxy holding the AGN and there is no excess other nearby galaxies? You don't need it to be in an environment with other galaxies. Is that what you showed because your peak was at 0?
Yes, that seems to be the case. It seems like an independent galaxy with no nearby neighbors can have an AGN.
Interesting.
I see there are a couple questions in the chat. Jared asks, how were the constraints based on U and R magnitudes and redshift determined? The constraints on redshift, the lower end was to eliminate foreground objects, and the higher end was to make sure that galactic evolution didn't play too big of a part in whether the galaxies I found had AGN. And the U and R band magnitudes, it basically boils down to that's the magnitudes that Sloan could see at those redshifts. And Jennifer Johnson asks, what is known about this subject already? I'm not sure if extensive research has been done about about the effect of different numbers of galaxies if those affect the formation of AGN. I do know that prior studies have suggested that having a galaxy very nearby can lead to a higher probability of having an AGN. But I don't necessarily believe that that is contradictory with these results because from my understanding, the reason that having a very nearby galaxy leads to a higher probability of having an AGN is because gas inflow from a merging galaxy can be directed towards the galactic nucleus, which causes it to become active. So a galaxy can be within half a megaparsec of another galaxy without them necessarily being currently in a merger. And additionally, galaxies with no nearby galaxies, that may be the result of galaxies having recently undergone a merger in some cases. So that may have led to them developing AGN. So I don't necessarily believe that my results here contradict previous results.